Okay, hello everyone. Good afternoon to you all. Yesterday I meant to presenting on automation and control for industrial purposes, but it's going to be like a storytelling thing. So just to say how we went from what was happening to where we are right now. And I'm not going to concentrate much on P&G related terms, but I can take a few questions on that also. Okay, so the first slide says the journey from the left to the right. So this was a very happy me, relaxed, and not having any problem to being on the site with so many people and having all the hotness and the wetness and everything. So how did this happen? What brought us here? I come from Nigeria, and Nigeria is one of the biggest countries, one of the biggest countries in Africa with the largest population so far. We have about 200 million people. Our electric power consumption per capita is about 144 kilowatt hour. Yeah, it's really poor. Yes, and we have most of our population are dependent on generators, and we have about 50 to 75% population connected to the grid. So we have a lot of load shedding. So one of the basic ways of reducing or maximizing electricity is load shedding. And the economic status is really being affected because of this problem. So here is what the electricity situation looks like. Installed capacity is about 12.9 gigawatts, but we can only get to the consumers about 5.4 gigawatts. And the problem we have is we have obsolete grid connection systems, poor plant maintenance, vandalism. And due to these problems, we have a lot of load shedding, and this load shedding are uninformed, so you don't even know when you're going to have the light, you don't know when it goes off, you don't know when it comes on. And averagely, on the average, we have about 4 hours of light per day and no power connections in some areas. We already saw we only have like 50 to 75% connection, yeah? So the adaptation, how did people adapt to this problem? Everybody started buying what we call a mini generator. It's a small generator that can be able to at least power your light. The basic problem we had was we wanted to move from not knowing when you're going to have electricity source to knowing when you can to have an electricity source. So it's easier for you to come back in the evening and turn on your generator. But at the end of the day, when we're collated based on our population, the amount of generators that has been installed in the country and the amount of power that these generators are capable of producing, it was surprising to see that we have a whopping 42 gigawatts from just the little generators. And now, it was good to know, but then it also comes with its own problems. We have a lot of health-related issues because of the hearing impairment, the smoke, and monoxide, and environmental effects. It had economic effects. This wasn't really obvious for a very long time until the SDGs came, the global warming, the climate change. And then we were like, okay, we tried to find a solution to our problem, but the solution we found to our problem is also causing another bigger problem. And I know you must be asking, why not renewable? Why not make the 42 renewable? It's easy to say, but just to give us a background, an average, So the average income for one person is around 100 euro per month. That's on the average. Some people earn a lot more, some earn a little less. But then, when we talk about what is the most feasible solution for us to implement based on the renewable resources, since we're talking about sustainable ways of generating electricity, solar came to mind. Why? Because Nigeria has a lot of solar radiation, a lot of it. And it's actually one of the most cheapest and easiest way for individuals to be able to be power generators, right? But then the upfront cost for around about 1.5 kilowatt solar solution will cost you about 2,500 euros. And then for the generators, it just costs 150 euro. Your guess is as good as mine. If you were earning an average of that, what would you go for? The generator. Very simple. Although we do not have maintenance costs and fuel costs in solar, which we have in the generators, but the fact that on monthly basis, this is what I have to pay my rent, I have to take care of a lot of expenses, I would easily go for something I can easily take care of, right? Because the cost comes gradually, even if over time it's more than what I'm going to spend, but because this is what I get, this is what I will go for. Also, the solar solution was a total black box. Nobody really understood what was going on in there. Everybody knows, oh, we have to buy new batteries all the time. Nobody really had a good technical know-how about the solar solution. But the generators readily available. And you have a problem, you just call your next door neighbor, the problem is fixed, you have light back on. The return on investment is way so high on solar solution. It's 8 to 10 years. And this is also not including the fact that you have to renew the battery almost every 4 to 5 years. The lifespan of solar is 20 years, attractive, but then we have to always 4 to 5 years renew the battery set. While the generators last 5 years, and to an average person, he says, I don't mind buying a new generator. But then we have a bigger problem. The biggest challenge with solar solution, even when we try to convince people to get into this market, is that the storage is almost 50% the cost of the whole solar solution. So this means if I am convincing you to install a solar system in your house, I am also telling you that in the next 4 years, you will be paying another half of that 2,500 or so. And this wasn't attractive enough at all because it was really expensive, the lifespan is short, and the technical know-how is also not there. And people who had earlier used batteries that had bad experiences would always share, so people were really scared to get into this market. So we started thinking. The first was, what could we do? How could we make this affordable for everybody? What are the solutions, and how can we make this solution something people can pay for, at least within the span of the lifetime of the batteries or the inverters or the solar? We started talking about the designs and everything. So we went, I did purposely a snake because it wasn't just a straightforward thing. It was, you define the problem, you try to find a solution, and then you get to a point. We found out majority of our problem was really thinking out a strategy on how to reduce the cost from the individuals to every other, maybe to the suppliers, or maybe give us some kind of a strategy on payment plan or something like this. So we kept on going through this process, board drawing solutions on how we can be able to solve this problem. We detailed the design, we tried to simulate the design. It worked very well in the simulation. And then we went to the field for deployment, just to test waters. And after installing in some few places, the backdoor neighbor who normally uses his generator to run this refrigerator turns his refrigerator on your inverter and everything goes gaga, and he comes back and says, it doesn't work, you know? So we needed to find out not just a solution that solves a problem, but also an automated solution that helps even the novice to really take care of this system with your presence or without your presence in this environment. So this was all the considerations that we took into, we paid. Our capital investment, our operational costs, the maintenance costs for the system, the product quality, the reliability, very important. We were always measuring our reliability. The safety, how safe is this in the person's house you're going to install it, because we all know that batteries have their own limits and can easily run away, especially the lithium-ion batteries. So you need to be sure that this person really, really understands the implication of having a battery in his or her house. And then also Nigeria is also a very hot place. It's a very hot environment, so this you also need to put into consideration. So our waste production, whenever these batteries are obsolete, what do we do with it? We needed to put this into consideration. Redundancies, environmental impacts, and so on. These were all the considerations we made. So we came to our first solution for the household, the smaller household. And our first was, okay, install just inverters and batteries. Don't worry about the solar. Pick 2 batteries, power the low power consuming things in your house. You need lights, you need your television, you need your fan. You can do without your refrigerator. Allow the grid to just handle the refrigerator and allow the grid to handle your air conditions. Then whenever you have the mains charges up the battery, and in the night you're home, you can easily just run your inverter and still have light like there was mains supply. This is one solution. The next solution was, for those who had a little bit more money, you can also install a little bit of solar to this solution that we had before. And what this does for you is that you don't just have power from the grid. So some days when you have maybe load shedding for 1 day or 2 days, you still have light because your solar definitely charges your battery. And the third, which is the most important one at the moment, is a solar home system. Now, why is this very important? We also noticed that during the installations, it's not just about installing the inverters or the solar in the house, it's also about the efficiency of the electronics that uses this power. So if you don't change your old equipment, it would feel like you don't even have, your battery doesn't work because it consumes a lot more than it should normally, which, your bulbs. So we needed to move into solar home systems, and with solar home systems, we started inventing energy-efficient bulbs, energy-efficient refrigerators, energy-efficient fans, and everything. So this comes like a package. But then we are still thinking of how to get this to start paying like they pay in mains, because people are willing to pay for the grid supply because it comes not in bulk, but in bits. So this was what we tried to implement with the solar home system. And this is only for the household and the small businesses. So back to where you saw me. For the big businesses, they also had the same problem. So I worked with the telecommunication firm where we had a project for about 4,000 sites. And the basic problem with telecommunication sites is that they need constant supply of power. It does not need to go down for any minute. So the PRA expected on these sites are like 99.9% on daily basis. So because of this, we knew we could not generally do away with generators, but then we had to adapt the system. So adapting the system means we made it a hybrid solution. So we had a generator, and we also had solar and battery connected to it. And then we had some intelligent systems that also move our load depending on when we have solar supply and when we do not have solar supply to be able to power the sites. These are very heavy sites. They are 48 volts, and they are quite very energy consuming. And at the end of our installation, after 1 year of monitoring, we realized that we were able to save 30 to 40% primary energy. That is, the diesel saving was about 30 to 40%, and this is also reducing our carbon emission by that same percentage. So this is how I got to this point. And then the energy management, which is really the area we now started looking into what can we do and how can we actually get these solutions to be more acceptable, not just because people know the problem, but the thing is what they can afford and how can we make it easy for them to access the solution. So on the supply side, we started thinking about smart grids. Now, remember earlier, we said our grids at the moment are quite obsolete. So it means for us to implement a smart grid, we must at first upgrade the existing grid to be able to carry the capacity it has. Renewables fluctuate a lot. So because of this fluctuation, we cannot directly implement the renewables on conventional grids. So we needed to do something, make our grid smart. And what would this do for us? It would reduce our carbon emission. It would also make that 42 gigawatts you saw. Imagine that we have solar, that we are able to convince that population to install only solar. Don't install battery, no problem, because you can be grid connected. Since our grid becomes smart, it can be able to handle grid connection. So these people have a source of revenue, one. Secondly, they also have a source of balancing out how much energy they use at the end of the year. And thirdly, they don't have to worry about the cost of battery. And even if they have to buy the battery, they don't have to buy the very large size battery. They could just buy a very small battery. And imagine what this would do to Nigeria. It would also increase our general power supply on the grid by 42 gigawatts. That is quite a lot of numbers. So the prosumer possibility will be made, and then we'll have a very good opportunity for energy mix. On the consumer side also, we had a lot of work to do. And one of the things we had to do was to sensitize people on how to use energy efficient devices to be able to manage their energy use. One of them is smart meters, to install smart meters so that people can have visuals on what they use, because visuals for me speaks louder than telling me numbers. So when I see, oh, normally this is this, and I can see equivalently, oh, I have already used €100 just in 2 days. No, something has to be done. So visuals was really important to us, so smart meters. Secondly, we started advising and educating people on energy efficient devices. They are quite expensive, but on the long run, they save a lot more. The smart devices in the house, your refrigerators, your fans, your light bulbs, your washing machines, and everything. The wash code. We think washing hot is best for our materials. Yes, for some of the materials, but if you really want to be energy efficient and you want to reduce carbon, you must have to come down a little bit and wash cold. 10 degrees of heat can save us quite a lot of carbon. The next is building optimization. So the buildings are done already and we don't need them to demolish their buildings, but we can optimize these buildings. The type of curtains you use, the type of windows you use, and all those things, so we can work on this. And for those who have new buildings coming up, we're trying to work with the government to see that we actually put into consideration the building optimization procedures into those buildings, and we don't have to do them after the buildings are done. Cook smart. You can cook so many things at a time. You don't have to cook one and the other and the other and the other. Load shifting. Load shifting is very important, and one of the reasons load shifting is very important is we must have smart devices for us to do load shifting. So on the dot curve, you could move all your heavy consuming devices, your washing processes, and everything to the load shifting, and then you can gain some benefits and reduce also your energy costs by washing on the dot curve or doing more of your jobs on the dot curve. Unplug all unused devices. This is simple, but it's also one of the biggest problems because it made no sense that when you leave your system plugged, that it still consumes power even when it is off. But this is one of the salient consumers in the house. And then coming to the industrial side, this is also part of home, but also a little bit of industrial. So smart thermostat. Most industries at the moment and most homes, in Nigeria, I don't talk about smart thermostat because it's already hot, so we don't need heating in our houses. We don't need heating there. But then in industries where you need to heat something to some, maybe you need to heat your process to a certain temperature and stuff, smart thermostats are really, really necessary. So you need a smart thermostat to only get to where you want to be and maintain where you want to be and not over or under. And then alongside with the smart thermostat is also installation of a lot of sensors. Sensors are really, really important. Sensors can be able to help you to reduce a great deal of energy and also save you quite a lot of investment. The next is conserve water. Conserving water by simply changing your aerators. It's very simple. Change your aerators, change your shower heads to more efficient ones. If you conserve water, you indirectly conserve energy, you indirectly conserve carbon, reduce your carbon emission. Lights off. Whenever you're not using your light, put it off. In companies, especially, I find it quite interesting that it's really easy to say lights off, or you just move, you shut off the lights, but in places like companies where people are busy running up and down thinking of one thing or the other, it's not that easy to just turn off your lights that easily. So if you can implement an automated lights off, sensor-controlled lights, this can also bring a lot of benefits to the company. So whenever anybody's out and the sensor notices no more movement, it turns off the light. Use washers in full load. In companies, we have washing processes, we have their kitchens, we have so many things. So if we can implement using washers in full load, that can help in the energy consumption. So utilize all energy reuse opportunities. This is where this comes to where I work, what I'm working on right now. So if we have processes that use heat and you need heat some other places, you can begin to think about using heat exchangers. You can begin to tap heat from one point to the other, or you can also begin to reuse energy from one process to another, not just arranging our processes and letting our processes just flow. Reuse water, low concentration principle. The low concentration principle simply states that if you have two processes that are alike, but one has more concentration than the other, it is easy to just reuse the water from the place of lower concentration to the one of higher concentration. And in this so doing, you conserve quite a lot of water. This was one of the projects I did with Procter & Gamble. And we were able to conserve about 75% of water from just one of the processes. So imagine implementing this in quite a lot of processes, how much it can bring. Optimize processes, develop energy and water use feasibility. So optimizing processes, normally in industries, we have processes already installed. That we know it works this way doesn't mean it should continue to work this way. Give room for new inventions. Always think out of the box. Try to optimize your processes over and over and over again. Optimizing processes can show you black boxes, little blind spots where you can be able to optimize or utilize a resource that you waste from this place. And developing energy and water visibility for your whole plant goes quite a long way, because when you compare how much water and energy and how much carbon footprint this brings to a company and you put it to a picture, what we usually do is you bring two cars, Ferrari cars, and then you compare, you show both of them colliding to each other, that's the accident, and write how much is lost. And then you draw a map and say, this is how much water we use only in this process. It relates to people a lot easier. So people can say, wow, it cost this much. So this is one of also the processes that it's very simple, but this brings us quite a lot of results. And with this, thank you.